So this one, you have to know by name. Like, you have to be on a first name basis with this theorem. Okay, that's how well we have to know this theorem. This is called the intermediate value theorem for continuous functions. It's IVT. We do refer to it as IVT. Okay, so this is the intermediate value theorem. The reason why I love it is because it's such a powerful theorem, one. And number two is it's based on so much common sense that once you hear it, you're just like, well, yeah, of course, that's how it's supposed to be. Okay? All right. So here's the premise. You have a function on a closed interval AB. What does that mean on a closed interval AB? That means at A, you have a solid endpoint. At x equals b, you have a solid endpoint. And there is a closed interval from A to B. That means this is all the points starting at A, ending at B, inclusive. Okay, so now we have a function on A to B. Okay, now, now I'm also going to tell you that this function from A to B is continuous. So you know what that means, right? You can trace it from A to B without having to remove your pencil. Okay? Now, this is f of A. Here, that's the y value. And this is f of B. All right? And here are all the other y's in between f of A and f of B. Here's my question for you. Would you say that if you were to trace this function from A to B, okay, would you say that in doing that, you're going to hit all of the y values from f of A to f of B?
Yes.
Yeah.
Why not?
Because there's no more.
That's fine, there's more. But are you going to hit every single y value from A to B?
Yes.
Yes, that's the intermediate value theorem. It's such a duh theorem. All it says, that's all it says. Okay? But there's all those words and symbols, but then when you really sit back and try to make sense of it, you're just like, oh my gosh, that is like so logical because it's calculus and it's logical. Okay? So a function that is continuous. So now let's read it with this in the back of our mind. A function that is continuous on a closed interval A to B, continuous, takes on every value between f of A and f of B. Well, yeah, of course it does, because it's continuous. It's got to fit all of those y values, okay? Because it's so cool. You'll see later how much applications it has. Like, it's such a, right? Most of the theorems in math, you read them and then you're just like, oh my gosh, is that even like a theorem? Well, yeah, it's common sense. So a theorem is something that can be proven based on other conjectures. The definition of a theorem is not something that's complicated. The definition of a theorem is something that can be proven with definitions and other stuff. So in other words, if y naught is between f of A and f of B, this is the important part now. Y naught equals f of C exists for some C in A to B. What it is also saying is this. If there is a point, I'm so excited now I'm yelling about it. Okay. If there is a point C in between A and B, okay, then f of C has got to be between f of A and f of B. That's what it's saying. So if there's a point in between A and B, its y value has got to be between f of A and f of B. Okay, which is more of what we just said. Okay? All right. So now let's do this. Take a look at this one. This is a piecewise function. Okay? And there is a split at x equals 2. So I have a function that exists to the left of 2. I have a function that exists to the right of 2. The function to the left of 2, I know it, it's 2x plus 3. The one to the right of 2, it's ax plus 1. what would the value of a have to be in order for this to be continuous? Right? So let's take a look at this. So this is x equals 2. The function that exists to the left of this, right, is the top function. And at x equals 2, what's the value of it? 7. Right? It's 7 for this function, correct? Huh? Take a look at the function on the top, 2x plus 3. At x equals 2, what is its value? 2 times 2 is 4, plus 3 is 7. Now, in order for this to be continuous, we want the function to the left to have the same value as the function to the right. So, at x equals 2, we want the left function to have same value as the right function. Okay? That means at x equals 2, we want 2x plus 3 to equal ax plus 1. Okay? So let's plug in 2, because we want this to be at x equals 2. Now, can we just find a? So this is 7 is equal to 2a plus 1. 6 equals 2a, a equals 3. So when a equals 3, in other words, okay, in calculus words now, if a equals 3, then the limit of f of x as x approaches 2 from the left-hand side equals the limit of f of x as x approaches 2 from the right-hand side. And that is like so mathy. Okay?